This video is an introduction to solving radical equations. So there's a couple of things you need to understand when you solve a radical equation. You need to isolate the radical. So, what is a radical? It's a square root, could be a cube root, fourth root, whatever. But that's the radical sign, right? So whatever's under this is considered the radical. So we're going to isolate it, meaning the only thing that's on that side of the equation is just what's underneath that radical sign, okay? And then the second thing that we're going to take into consideration is we're going to check for extraneous roots. Now, extraneous roots are roots that you solve for. You actually got them, you solved them, but they do not satisfy the equation. All right, so anytime you have a radical equation, you're going to have to check your solutions to see if they are viable. Meaning, do they work? Do they satisfy? Does the left side equal the right side, from an equation? So, I'm going to hit pause, or you need to hit pause here to copy down what I've just got right here on this screen, okay? Hit pause now. All right, so hopefully you've got this copy down. Let's go ahead and start looking at it and an example, okay? So solve this equation. First off, is the radical isolated? Meaning, is it only thing that's on one side? And the answer to that's yes. So what we're going to do is, this is a square root. So we're going to square, that's how you get rid of a square root, is to square it. What you do to one side, you do to the other. So we have m is equal to 121, okay? That's what m is equal to. Now, I got to check it, meaning I need to put this underneath the radical, substitute back in for n. That checks out. So 121 is a viable solution, okay? If this over here did not check out, then we would have what is called an extraneous root, even though we solved for it, okay? Now, let's do another. All right, so pause here and let's see what you can do, okay? All right, now that you've hit pause and you've come back and let's check, let's compare what you did to what I did. One, is the radical isolated? The answer is yes. So what we're going to do is, how do you get rid of a square root? You square it. What you do to one side, you do to the other. So everything underneath that radicand, or that radical, the t minus 1, which is called the radicand, everything underneath that radical is going to go away, okay? Equals 9, so I'm going to add 1. So we got t is equal to 10. Now, that's just a temporary solution until we check it. All right, so let's check it. 10 minus 1 equals 3. So that's square root of 9 equals 3. Does 3 equal 3? Yes, it does. Okay, so we have to check every solution to make sure that it works. All right, let's look at this one. So hit pause now to see if you can work it, and then resume after you get done working it, or as far as you can go. Okay, so hit pause now. Okay, now that you are comparing your work to mine, is the radical isolated? And the answer to that is no. So we have to move this 7 over to the other side. It's going to give me the square root of x minus 9 is equal to 15. Okay. Now that I've got my radical isolated, let's go solve it. I'm going to square the left side. I also square the right side. That's x minus 9 is equal to 225. I think that's 15 times 15. Let's check it. Yep. And then I've got, let's see, I'm going to add 9 to that. So x is equal to, let's see, what would that be? 234, right? Now, that's great. we got a solution. We just don't know if it's the right solution, or if I shouldn't say it's the right solution. We don't know if it is an extraneous solution, meaning something we solve for that doesn't satisfy. So let's check it out. So we're going to say square root, or 234 minus 9 minus 7, does it equal 8? Well, square root of 234 minus 9 is square root of 225 minus 7 is equal to 8. So that's 15 minus 7 equal 8. 8 equals 8. Yes, it does. So 234 is a viable answer. Now, yes, you have to show it every single time. Okay, you have to check it. You have to plug it in. You cannot just assume that 234 is the answer, because it may not be. It may not work in the radical. Now, let's look at another one. Now, hit pause now and let's see what you can do with this one. It's very similar to the previous one, so let's make sure that you're good. Hit pause now. Alright, so you should have had time. You hit pause, you should have had time to work it. Is my radical isolated? And the answer to that is no. We're going to move that 6 to the other side. Now it's going to give me square root of 4m minus 15 equal to 4. Now that I've got my square root isolated, I'm just going to square both sides. Okay? Because that's how you get rid of a square root. You square it. Okay? So the radicand comes down, which is everything underneath that radical, is equal to 16. And now we just solve. Plus 15. And so I got 4m equals 31, I think. Yep. So divide by 4. So m is equal to 31 over 4. All right. Now, that's great. We need to check it. So let's plug it in. So that's 4, 31. That's 13. 31 over 4 minus 15 minus 6, is it equal to negative 2? Well, we're going to see. The 4's here cancel, so that's really the square root of 31 minus 15 minus 6 equal to negative 2. So that's really the square root of 16 minus 6 equal to negative 2. So that's 4 minus 6 equals negative 2. Yep, that works. That's a viable answer. Okay. So let's do another one. Hopefully you were successful with that. Okay, and hopefully you were checking, plugging it back in to check. All right, let's look at this one. So we've got a radical isolated. That's great. We're just going to square both sides. Now, it's great for the left side because we know it's just going to be x plus 17. But the right side, well, that's x plus 5 and x plus 5. Okay, so if you remember, you got x plus 17 equal, we take this first term times everything, and then that second term times everything. You remember that? Yep. So we're going to say x times x plus 5, and then plus 5 times x plus 5. Okay, so that's x plus 17 is equal to x squared plus 5x plus 5x plus 25. And now we're just going to get everything on one side. So we're going to combine some like terms right there. So I'm going to say x squared plus 10x plus 25 equals x plus 17. Now I'm going to move both of these at the same time. We get 0 equals x squared plus 9x. Let's see, 25 and 17, that should be 8. Okay. All right, so now I'm left with a quadratic, right? And we've been solving quadratics. You should know how to factor this and solve it. So here we go. What are factors of 8 that add together to give you 9, right? Well, you should know that that's 8 and 1. Because 2 and 4 won't do it, 8 and 1 does, okay? So that is x plus 8 and x plus 1. That's all set equals 0 because we're solving it, right? So x plus 8 equals 0, x plus 1 equals 0, so x equals -8, and x equals -1. Now, don't shortcut this. Don't go, well, all I got to do is take this right here and just switch the signs. No, you need to do all of this so that you understand what it means to solve it. Okay, we're going to be doing polynomial stuff later that this is going to be a helpful understanding. So do it now or do it later, but it's going to get you if you don't. Okay, now I've got -1, I've got -8. I got to check it. -8 plus 17 equals -8 plus 5. Now, that right there should give me square root of 9 is equal to -3. Square root of 9. Square root of 9 is what? 3. Does 3 equal -3? No, it does not. So -8 is not a solution. Okay, -8 is not a solution. Now, let's go try -1. So square root of -1 plus 17 equals -1 plus 5. Okay, so we got square root of 16 equals to 4. 4 equals 4. Yep. So in this problem, this one, -8, was the extraneous root. We solved for it, but it didn't satisfy the equation. So that's a big O no. And then this one is good. X is -1 is my only solution for this particular problem. Now, you could have had both of these not work, and the answer would have been no solution. You could have had one of these work, which is what we just saw, or you could have had both of them work. Okay, so that's your options. You will not know what option you have until you plug it back in. Okay, so that should be enough for you to kind of get a grasp on how to solve radical equations. You know, there's more to it. We're going to be doing some that take probably a page front and half a page on the back to do. So I need you to be solid in this, okay? So hopefully you've taken notes on this. The homework on this, I think, is Tuesday. It closes. So you've got enough stuff to do between now and when I get back on Monday. All right? So make sure you take really good notes. Make sure you're doing your reviews. And make sure you're getting that homework done. All right? Don't sit there and just piddle. Be responsible for your time and get your work done. Okay? That's it. So this concludes your video for notes for Thursday, February 27th. All right?